just sworn it used to be here.
No comment. All right, we are at time. We'll give another minute just because people are still wandering in, but we will get started momentarily. I think I'm starting. Okay, so this is the TLS Exported Attestation BOF. I will note that this room and many of the rooms in this hotel are very echoey. So make sure we try and stay quiet, as much as possible because everything just echoes like crazy in here. I'm Wes, this is Nancy. We will be your chairs that will shield Paul from thunder. And there's a mailing list that's already up and running. I suspect many of you are on it already. This is the Note Well policy. It talks about everything and how you would participate in the IETF. I'm not a lawyer, so I will not repeat it, but if you're going to participate at the microphone, you should understand it well. This is sort of the second page for the Note Wells that really describes a lot of the background. If you haven't read it, it talks about the standards process, how the working groups run, how the anti-harassment runs, the code of conduct, the copyright, and the patents of the participation, and then, of course, our privacy policy. A couple of quick points about the code of conduct, which is defined in RFC 7154. It really says treat colleagues with respect. That includes this group, which I think a lot of us know each other fairly well, and things can get heated, but do remember to speak politely, speak slowly, limit the use of slang, and dispute ideas with reasoned argument, not other forms of speech. We use our best engineering judgment in the IETF, and we find the best solution for the whole of the internet, and we contribute to the IETF as a whole. Reminder, this session is being recorded. If you are in this room, please do use the QR code that's on the speaking stand or the agenda to log in. That is how we track the participants in the room. This is a little bit of background information about EXPAT in particular. The whole purpose of this BOF will be to standardize a TLS extension enabling attestation of one or more endpoints. The data tracker is there for where the BOF request came through. I already pointed to the mailing list, and then there's at least one draft under consideration for the future of the working group if it's formed. This is what our agenda is going to look like today. The introduction is what I'm doing right now. Nancy will give an overview of her view of the problem statement in a minute. Paul is going to talk a little bit about why we're doing a BOF as opposed to looking for existing working groups. Then there will be 3 presentations about the actual problem statement, the use cases, and the design space. Note that during this time, we're only going to take clarifying questions after each presentation. We're going to be strict about this. There's plenty of time to discuss things later if you love it or hate it. That'll be after we get through understanding the problem space. And then finally, of course, we'll talk about the standard BOF questions of, is the IETF a right place, and is this a tractable problem, and all of those things. And if we get through that, we will move on to the charter and the scope-related discussions. So I will turn it to Nancy, who's going to talk about why we're here today.
Yeah, so before we get to the use cases and whatnot, our understanding of why we're here is that there are requirements, there have been requirements, but even more so today as we look at the different ways in which different deployments are using different devices, including the workloads that are further putting requirements to do verification of, and I'm not going to read these out, but you might have seen some of these claims to go more towards compliance or security posture, if you will, to go beyond the once you set up a session, what are the things that we need to do that eventually could lead you to ensuring the health of that session, if you will, and affect authorizations. And so there have been discussions, and I'll let Paul speak to that, but There are ways in which we can achieve that here in the IETF. There's a working group, the Remote Attestations Group, Remote Attestations and Procedures, that being RATS, in which there is an architecture and framework that allows us to carry these attestations. And the proponents here would like us to carry those in a TLS, not necessarily handshake, but within the TLS session. So that's our understanding of why we are here. And we asked Paul to give us the rationale of why here versus other working groups.
Right. So initially this work was presented in the RATS working group, and there it fell a little bit out of scope because it's very close to TLS, and the RATS working group is extremely busy, and so it didn't really get enough interest for it to become a work item there with a reasonable deadline to complete. The proponents then went to TLS, and there they've sort of had a similar problem. The TLS working group is very busy. They're not very active in the attestation space. And so they also felt it was not entirely on target for their working group. And so there was also less of a priority for them to work on. So they were also not against it, but not really in favor of doing the work there. So then the proponents came to me and asked what they should do. I felt that AD sponsoring this would be tricky because it is not a very simple, easy, a document where everybody agrees on the problem, everybody agrees on the solution, and we can just like pop this out very quickly and continue. And that's really a requirement for if you're going to the AD sponsored route. Going to the independent stream is also not really the best solution because there you really don't want to pick up topics for which there are working groups that are better suited. So to me, it seemed that like the BOF was the best solution to do this. So we could talk a bit more about the problem space, the solution space, and see if you could maybe just find a new working group where we can work on this. And then obviously during scheduling and things, we will make sure that it doesn't conflict with either TLS or RAT, so that those interested people can also follow this potential working group if it forms. So that's sort of the history of where we were and why we're here.
So I think one important takeaway of that is we really need participants from both of those two groups in this one. So this is actually a benefit to have a single group that both sets of participants can attend. And as Paul said, we'll make sure they don't conflict if this is formed. All right, so we'll go on to the first of the discussions. I should have put the agenda slide there because it would have made it easier, but so we'll talk, Yaron, you can come up and we'll talk about the problem to be solved.
Can we show the slides?
Yeah.
There's only 3 of them. Oh.
Can you kick me out, or we should stop? There we go. I got it. Yeah.
Thank you, Wes. I'm Yaron Sheffer from Intuit. Yes. So obviously, TLS Handshake uses X509 certificates to authenticate 1 or 2 of their peers, but there's often a need for 1 or both peers to say something more, to be able to know more about the actual security of the platform that it is talking to, or security posture of the platform that it is talking to. Specifically, these considerations apply mostly to confidential computing use cases, and my favorite use case in this area is I want to talk to a high assurance API, something like key management infrastructure, where I need to have the most assurance possible that I'm actually talking to the right peer and that the peer has not been meddled with. So people implement this sort of high assurance APIs on top of confidential computing infrastructure. And that, under various names, such as enclaves, is available today in most cloud environments. So it is widely available across the industry. All major cloud providers have some sort of confidential computing infrastructure available. Often, especially in the initial stages of setting up the connection, I would like to have the assurance as soon as I finalize the connection setup, which leads to the idea of why don't we bind the remote attestation? Why don't we bind the retrieval of this assurance into or next to the TLS handshake? And so people came up with lots, I think 10 to 20 different solutions that do that, various variants of TLS with attestation somehow. So the technology is there, and there's a very clear need in the industry. People are actually doing it, but there are no standards, with one exception that we will mention later. And this is what we are trying to address here. So having a portable or interoperable solution for verifiable attestation over TLS. And just to give an idea, TLS certificate basically has two things. An identity and some form, usually a DNS name, and the public key, and that's that. The evidence, the attestation, provides you potentially with a lot more information about the platform that you're connecting to. Runtime information, measurement of the initial state of the platform, and so on and so forth, as well as arbitrary data. And that can all be kept fresh, or the peer can be assured that this information is fresh using nonces that potentially come all the way from the RATS verifier or the relying party. So you can have reasonable freshness guarantees for this evidence, which makes it trustworthy again. So the high-level plan is to standardize a solution using TLS Exported Authenticators, which is an existing RFC, where we don't modify the TLS handshake, but we use a post-handshake solution to upgrade the TLS connection, where you start with your normal TLS connection authenticated by a certificate, and you end up with a connection that's authenticated and has the remote attestation guarantees bundled into the same connection. The plan is to use TLS 1.3 with no change to the handshake. So just using the exported authenticator RFC. And again, RATS with no changes to the RATS architecture or the RATS components. To use both things coming from both working groups as building blocks for a solution. And we would like to keep the working group very narrow, to focus on this and this alone. And when we get to the charter, you will see it and declare success. Thank you.
All right, so a reminder that there are use cases in design space coming up in a second, but does anybody have clarifying questions that you didn't understand sort of the beginning of this problem space?
Dave, you're in the queue.
All right, Dave Taylor. Don't know if this is answered in one of the later ones, but I think this is about the problem to be solved. And so let me ask my clarifying question now. Once you've attested, what's the expected lifetime of the attestation in the problem? In other words, is the attestation supposed to last until is it for the lifetime of the TLS session, or is part of the problem that you need to be able to reattest during the lifetime of the TLS session?
So I think this is more than a clarifying question. I think this is something that we will need to discuss actually as part of the work on the protocol.
Okay, I didn't know if there was a problem, if this was a requirement or a non-requirement. And if you're saying you don't know yet, that's fine. Okay.
So freshness and ongoing attestation is something that we've been discussing extensively. I don't think that there's a solution, and it will need to be discussed by a working group once there is one.
Hi, Stephen Farrell. So it really is a clarifying question, and it was answered in the chat, but it'll be interesting to see if you give the same answer. On slide 3, you mentioned relying party. My question was, is the relying party the TLS client?
The other TLS peer, so not necessarily the client, it may be the other way around.
Okay, that's the same answer as I got in the
But
chat.
yeah.
Another clarifying question. So TLS exporters, so I guess the main question here is what is being authenticated or attested? TLS exporters would imply that we're using TLS to authenticate or attest for something else like application layer. And there's stuff in the chat that hints that people are thinking of that. But then this slide here also says to upgrade TLS itself to be authenticated and attested, which would imply a TLS imported authenticator. So can we clarify what the goal is?
So, yeah, could you please stay, because I'm not sure I fully understand your question. So
the question is, are you trying to authenticate TLS, or are you trying to authenticate like an application layer protocol using TLS?
I'm trying to authenticate the connection that's set up through TLS and the extra something that we add at the end. So there will be authentication and attestation, and let's not confuse the two. But both of them will provide security properties for the one connection that we set up. Does that make sense?
So you say the one connection, is this outside of the TLS protocol that you're authenticating, or is it the TLS protocol connection itself that you're trying to authenticate?
It's the TLS connection, yes, the TLS connection, and then the exchange of from a TLS point of view, at the application level, we exchange additional information. And once this is done, you still have a connection useful for the application, but now it has these properties of both the authentication and the attestation.
Okay, so I'm still slightly confused, but I'm not going to push it. What I'm confused about, maybe this will highlight as you go further, is whether you are importing authenticators or exporting them. Because it can very easily become a circular logic in terms of like a security reasoning, that if you establish TLS and that's supposed to authenticate something at the application layer, then it's used back to import to authenticate TLS. What is the end goal?
So EXPAT stands for Exported Authenticators. The authenticator is exported out of the handshake and into this post-handshake negotiation of attestation.
So
But
I
yeah,
think,
this is
Okay.
going beyond clarification.
I think
Yeah.
this will come more clear after the next couple of
Okay, because
presentations.
on
So
the
let's
slide it says to
continue for the
upgrade
time being.
TLS to be authenticated. So there's a disconnection here between what's being stated and what's on the slide.
Okay, so we'll bring that back at the open microphone later, because that's a critical question. Your points are valid, but let's go on for the time being. So let's go on to the second presentation, which is the use cases, and Thomas.
Hello. So I'm going to talk about use cases focusing on confidential computing, because we know there are other kinds of use cases. We've seen them in IoT, especially edge, and some of them coming up from the mobile network as well. But the real problem we're trying to tackle now is that related to confidential computing. Thank you. But before delving into the two use cases that I wanted to present, I first wanted to step back a second to introduce the concept of a confidential workload, because I'm not sure whether everyone in this room is knows what we mean by that, and therefore, we want to page in the concept in your memories before we can actually use that in the use case description. So a confidential workload is, first of all, a workload for some kind of application logic, some business logic that performs some task. It can be, packaged as a process, as a container, as a bunch of container that collaborates, or as a VM. That doesn't matter, right? The packaging is completely orthogonal to the concept. The idea is that this thing, this aggregate of bits, does some work. And what makes it confidential, which is the interesting bit here, is the fact that it executes within an environment that provides some further guarantee in terms of protection of its runtime state across the two dimensions, memory and CPU, so that external attackers, including sibling workloads that execute at the same privilege level as this workload, but also, interestingly, higher privileged software like your host kernel, your host hypervisor, they won't be able to fiddle with your memory, and they won't be able to inspect your memory. And this is pretty counterintuitive compared to the normal, hierarchical kind of execution model and privilege model in a traditional platform, where the host hypervisor, since it needs to manipulate the memory content and the CPU state in order to present you with the illusion of, the virtualization illusion, it has to look into your memory. It has to fiddle with your vCPU state, including registries and stuff. No, that's on a confidential computing platform. This is not possible. This is the sort of novel part here. The way the confidential computing platform provides these guarantees is by a mix of things, including instruction sets extension, including microcode, firmware, specialized hardware. All of that is hooked into a special component, which is the root of trust of the system, which you can intuitively think of as the read-only memory code that executes at resets of the platform. So every time the platform is reset, the instruction pointer will go there, and there's no way to circumvent that thing. So the root of trust will always execute first, and establish the chain of trust, where from early bootloaders the bring up progresses up until you have a fully operating execution environment like, you know, a normal OS. Okay, so this is the concept. The green thing here is an interesting thing to visualize it also from the perspective of the attestation story, because what you get from evidence when you're asking from evidence is exactly the projection of the TCP state in terms of the security metrics that matter and that represents that security state, including, you know, platform identifiers, measurements of each of the components that were booted, measurements of the workload itself, configuration parameters, and whatnot. So that a relying party that has that evidence blob can actually make sense of the security state of the peer that it is interacting with. Yeah, so this is fairly novel, but not really novel. There's going to be further evolution on that for sure. But we're already seeing, you know, the second generation of this stuff popping up. And as Yaron was mentioning before, this is not just your hardware vendor, it's also your cloud service provider that gives you the packages this offering and makes it available to you today. So now going to the use cases, first of all, the first one that I wanted to present is secrets provisioning. So imagine you have a workload, your confidential workload needs to deal with some privacy sensitive thing or some IP, right? So you don't want that to be seen by others. In particular, if you want to deploy that on a cloud, you don't want to trust your cloud provider with any secret, right? So, and why you shouldn't. And so one way to actually deal with this situation, which is quite typical, is to split your application into 2 bits. You first bootstrap to a thin layer that only contains an attester agent, which is a piece of logic that only does 2 things or 3 things. One is to call back home to your trusted services, right? To establish a secure channel to your private trusted services, and then on top of that, execute a remote attestation protocol by which the confidential workload requests evidence from the platform, you know, engages in the challenge response with the verifier or the relying party on the trusted services. And when the trusted services end is convinced that the peer it is interacting with is not only the confidential workload, but is a confidential workload executing on that specific platform that provides the isolate guarantee, then okay, the policy checks, thumbs up, I'm going to give you the secret, whatever the secret is. Secret could be a key, okay, a key to unlock a root FS and then bootstrap onto the fully functional operating system, but it could be also, say, for example, an ML model that your workload needs to, in order to do the work, or a combination of the two. Or it could be also the entire image, right? So whatever a secret is, that pattern applies. Second use case is that of privacy preserving collaborative computation. In this situation, you have, first of all, let me step back. An instantiation of this is the data clean room. I'm not sure you've heard of it, but it's quite popular. And the situation is where you have a multiple mutually distrusting data provider that needs to feed some data sets that are riddled with PII into this data clean room where some sort of computation is executed that needs to meet some regulatory regime, okay, which make sure that the data sets are not shared. Everything stays within the confines of of the execution environment, etc., etc. So in order for the data provider to trust their data with the data clean room, they need to first establish a secure channel, and then on top of that run in remote attestation where the data clean room, the confidential workload, would present evidence that convinces them that it's the workload they intend to collaborate with, and also it's in the state they expect it to be by means of the measurement. So the measurement that coming from evidence, you can think about it as sort of a lookup index into a, the list of trusted trusted logic, business logic that that you as a data provider are going to accept as a peer in the connection. Same thing on the downstream, where once the computation is done, you can imagine it as some ML model that has been refined by data being pushed by the data provider. So data is consumed by the downstream guys. They also need to make sure that the the secure channel they are establishing with this is attested as well, because they need to know that the regulatory regime that they need to abide to is implemented by that guy. So last one, just reiterating what Yaron was saying before, these are a list of existing products in the market. They all implement some flavor of attested TLS, all of them different. But yeah, it's just to show you that there is market pressure for this thing. And when you talk to this guy, that what they tell you is that this is not a market differentiator for them. This is infrastructure. They need this as an infrastructure bit. So from their perspective, having an open source implementation of a standard that has been verified, formally verified, would be ideal. And by the way, two of them have also committed to provide an implementation of this. So that's encouraging. Thanks.
All right. Is there any really quick clarifying questions people have about the use cases? Otherwise, then let's go on. Thank you. I'm over 4 at this point. 8, 9.
So welcome everyone. I'm Usama from TU Dresden, and I want to start by thanking my sponsor. My sponsors who helped me being here: Confidential Computing Consortium, GenXT, and Teleport. As Thomas already pointed out, the use cases. So I want to go a bit technical about what are the possible solutions in the whole design space with which we can achieve that. And this slide actually shows 3 of the possible things, 3 of the possible technical solutions in which we can achieve that, meaning that we want to combine remote attestation with TLS protocol. One is giving the guarantee about what is the state of the machine we are talking to, what is the firmware, what is the software and hardware that we are communicating with. The other side of the picture is the TLS protocol, which is saying that what is the identity of that specific machine that we are communicating with. And we can combine both, which is the attested TLS. That's the whole idea of the protocol, that you not only get an identity verification, but in addition, you get an idea of what software, firmware, and hardware is underneath that. So most important from remote attestation perspective is the attester side. When is the signature done? Because that's the point in time when the claims will be fixed and protected. And that's the most important thing. So signing of the claims, if it happens before, we call it pre-handshake attestation. If it happens in between the TLS handshake, we call it intra-handshake attestation. And if it happens after the connection has been established, we call it post-handshake attestation. And that's what is shown in the diagram. We have, of course, by adding now attestation to TLS, we need to change something. And that something is exactly shown in this table, that what do these solutions need to change. And the idea here is that pre-handshake attestation and all of those basically need to change protocol, meaning the TLS protocol changes. But there is a difference between the level of the changes, meaning that the intra-handshake attestation needs to do invasive changes in the protocol itself, while the one we propose, like post-handshake attestation, is only required, uses the TLS protocol as is, and can have possibly negotiation extensions to that. The deployment side, the pre-handshake attestation needs to modify the certification authority, registration authority, or the trusted authority. And at the application layer, the post-handshake solution needs to modify the application layer. I want to point out that the application layer changes do not necessarily mean a change in the application. There could be a runtime running in parallel to your business logic, which will ensure that the changes are not made to the actual application or the business logic. So there is a lot of fragmentation in the industry, as already pointed out. Like this slide shows 17 prominent solutions. Of course, there are much more than that. But the point we want to highlight is that there is definitely a need of some standardized solutions so that can be formally verified, analyzed, and then proceeding with that for the use cases. So I want to now go to a little bit of detail of the table that I was showing in the previous slide to give you an idea of the whole design space. What are the kind of trade-offs and what do we gain and what do we lose? Mostly I'm going to talk about the limitations because the kind of benefits are related to that. If I'm changing application in post-handshake, of course, I'm not changing, that's not changed in others. So that's a kind of a benefit and trade-off in that sense. So general limitations here mean that basically they apply to all solutions in the tree that was shown on the left side of the last slide, meaning that per session evidence freshness is not provided by any solution in the pre-handshake attestation. And I want to emphasize that this is really important, which means that the state which is given to me could have been possibly 1 year old or 2 year olds and so on. So we don't even know what point in time it was done in the past. The signing of the claims, which is shown on this slide in green, could be at any point in time in the past. So that's why freshness is really an important state that requirement that we need, that the point in time I'm establishing the connection, I know that the evidence was generated very recently. That guarantee is not provided by pre-handshake attestation. And example of this solution is attested CSR or CSR attestation. And as I said, general limitation applies to all solutions and naturally applies to this one as well. In the intra-handshake, we can cover up the solution problem by of fixing the per session evidence freshness by doing it within that session. But as I said, it requires a lot of invasive changes in the TLS protocol itself, potentially going as deep to the TLS handshake, the key schedule of the TLS protocol, meaning that we need a new binder to bind it to the TLS client as well as to the TLS server so that we can be really sure that the TLS client and the peer that is the TLS server which participated in this session are the one which are represented in that specific attestation. And secondly, there are challenges other than that, which are namely, how do I get a status of afterwards the channel has been established? Meaning that if I see forward from the point in time where I am in, Richard, please.
You can finish your sentence.
Where I am in, so how do I know the status of what is happening after the channel was established? For long-lived connections, for example, which are required in confidential computing use cases which were presented, this kind of solution cannot help us in that case. Yes, please.
Yeah, so that timeliness thing was something I wanted to push on. So
can you speak closer to the mic?
So the timeliness thing was, I just wanted to kind of get clarity there, because the confidential compute things I'm aware of, you know, once you're talking to a thing that's in the enclave, like, and as long as the session continues, it's in the enclave. And so I wonder why there's this timeliness concern. If you're worried about something like, you know, a binary taking the TLS state and passing it outside the enclave so that it can continue in some untrusted environment, well, don't do that. Like, that's something your attested binary shouldn't do. So I just wonder if these timeliness constraints are actually meaningful given the way the enclaves actually work in reality.
So the way I'm understanding your question is that, is the time really important? Is this a good phrasing? Okay. So I would say it's really important, because if the firmware update has happened and I was given an older evidence in which the previous firmware version was there, so how would I know that the firmware version has been updated on that specific
How,
device?
you're going to upgrade the firmware and keep the TLS session up?
Sorry, can you say again?
It seems like you're presuming some firmware upgrade has happened without tearing down the TLS connection.
Are you asking that I am doing it without tearing down the TLS connection? Yes, that's right. So
Okay. I didn't know that was possible.
I may be not understanding your question correctly. Can you?
Okay.
So why don't we table this for the time being?
Thanks.
Because he's getting it on the next slide where I think it resolves some of this too.
Okay. Yeah. It does seem salient though, because if this timeliness concern doesn't exist, then this distinction between at handshake time and post handshake becomes less salient.
Yeah, it's a good question. Bring it back, please.
Right. So post handshake, the time signatures are done after the TLS protocol has the TLS handshake has finished. That means now we already have an established connection, and this solution has the problems that it requires application layer changes. I already pointed out that application layer changes do not necessarily mean application changes. That can be something else like a runtime to do that. And there are latency impacts, but they are small. Also, I want to point out that it's only for the first authentication request. You send an authenticator request, you get back an authenticator. That's only 2 round trips. Whereas if you establish a new connection, you need a 3 round trip. So for the afterwards of the first authenticator request, you actually have a benefit rather than a loss. And in that solution domain, what we propose here is specifically that we want to use mechanisms, specifically meaning that exported authenticators, RFC 9261, which I already pointed out that basically is sending an authenticator and getting back, sending an authenticator request and getting back an authenticator. And that authenticator will basically consist of the certificate message in that authenticator would actually be extended with the evidence. So we will have guarantees about the PKI that I'm still talking to the same server. But in addition, what is the recent state of that specific server at this point in time? That is the additional guarantee we will get with this. And we, as we do not change the TLS protocol itself, that's where our hope is that any guarantees which are provided by the TLS itself would remain as it is. But we also have a formal analysis ongoing in order to establish what exactly would be the problems or what kind of problems might originate. And from the RATS perspective, the format that we want to propose, like there are solutions, Intel SGX, TDX, ARM CCA, AMD SEV, SNP, and so on. So several different formats are there. What we propose here is to use a conceptual message wrapper, which is already in the working group last call, in the RATS working group. And the idea here is that with this format, we can take care of all the zoo of different formats and then wrap them in conceptual message wrapper, and then we can utilize that. And I want to make a final point before I go to you, Eka. So the work in progress that we have, the main property that we are intending to achieve here from a high level security goal is basically to be sure that the state which is given to us is of the same server for which we have the identity. That is, it's not relayed over from some other entity, that the evidence that I get is bound to the identity that I am getting. Yes, please.
So Ecker, really quickly before you go on, I think at this point, we'd like to hear any clarifying questions, of course, but I know this is going to devolve immediately into a more general discussion, which is just fine. So I invite, if the other proponents would want to come up, because I'm sure that you all want to answer questions, you're welcome to. A couple of points. So to the audience, right, the purpose of a BOF is to figure out, is there a problem that we want to solve? And is the IETF the right place to do it? And is it a solvable problem? To the proponents, please be aware that, when we take on a problem, it doesn't mean this is the solution we're going to pick in the long run. So don't, for everybody, please don't pre-assume that this is the solution, right? Things change in the IETF. With that said, please join the queue, and Ecker, please fire away.
Yeah, I'm just trying to follow the implied properties here about timeliness. So I perfectly well understand that I connect to you and you persuade me that you are a given binary and that I'm connected to the binary. I'm sending my data, right? And I perfectly understand that if you update your firmware, like that you can persuade me to add new firmware. My problem here is if the TLS connection stays up, then all the data I've sent to you, and you can change your firmware anytime, then I don't understand what the guarantees mean. Because if you can change your data to non-compliant firmware to non-compliant firmware that has access to the keys, then what all the data I've already sent you? So like walk me through like the model here.
So I'm going to rephrase your question in the way I understand it, and please correct me if I'm wrong. So the question from your side is that you can change firmware at any point in time. That's right. And what you are asking is that what is the benefit of checking it? Is that correct?
Well, no, what I'm saying is if that new firmware, okay, so if that new firmware has access to the cryptographic keys, which you were talking about earlier as part of the design in your interaction with Richard, right? Then it now has access to all the data that I transmitted to the old firmware. And so if I later decide that new firmware doesn't match what I expect, it's too late, right? So I'm trying to understand I do understand the idea of like reattesting the old firmware, because you're like, well, maybe I want to make sure things are still cool before I send data again. But like, it can't be the case that you can just replace the firmware with any firmware of your choice afterwards, because then the whole attestation problem falls apart. So like, I must be misunderstanding something important.
Okay, I suggest that we make it pending to the discussion. Is that fine for you?
I'm sorry?
He's asking generically. Go ahead.
Okay.
We're into the general discussion.
Into the general discussion, I mean, after this.
Yeah, no, with that question.
Yes.
I've lost the plot of what we're doing. Are we putting this question off?
No, it's just fine, Ecker. So I mean, I think the fundamental point that he is asking is related to the freshness of the evidence, right? And if things change while the TLS connection is active, I'm making it a little bit more generic than what Ecker is asking, right?
Mm-hmm.
If things change in the middle of the TLS connection and you continue to allow that connection to be established, then the proof that you've negotiated at the end is no longer technically valid.
Sure, right? That's a very generic problem, like time of check to time of use. We cannot solve it. That's a unsolvable problem.
No, that's not what I'm saying. What I'm saying is that the attestation has to come with a promise the firmware can't change. That's the point. That the firmware can't change without having the keys recycled. Like,
okay, Thomas maybe is answering your question. Is it?
Can I? So the attestation doesn't make that promise.
Then the whole thing is useless.
Sorry? No, it is not
then
useless.
The whole thing is useless.
No, because you can realize at a later point in time that something is wrong, and then you can shut down the tunnel. Then, of course, the thing that you have already shipped is gone.
I have gigabytes of data I sent you under the old cryptographic keys. And you're like, congratulations, I just changed to like a new binary that like exfiltrates all the data? That can't possibly be okay.
I mean, in particular, just to emphasize what Ecker said a minute ago, because you've already exchanged a bunch of data, and all the untrusted stuff in the middle could have been recording that data, and all of that's now compromised by the new thing that has popped up.
Right.
So it's not just that things that are compromised going forward. Everything you already did is compromised.
Right. The fix for this is don't keep the keys, right? Which is like totally fine. But that's what I'm trying to understand. That's why this is like a clarifying. It was intended as a clarifying question. Is trying to understand what we're trying to accomplish here. And I thought the answer was that like with many HSMs, that once you did the key establishment, like then the binaries couldn't change. But if you're so I'm trying to understand, which then wouldn't require like a retesting different binaries. But like if you're saying I can just change the firmware whenever I want, then I don't understand how any of this works.
No, the thing is that you change the firmware, but then a new remote attestation happens with the new evidence containing the measurements for the updated firmware.
But again, I've already sent. But again, that would be fine if the cryptographic keys were destroyed in between those two events. But if not, then changing the firmware is tantamount to exfiltrating the cryptographic keys, which undercuts the entire assertion. Like if at T0 I connect to your device, and you absolutely persuade me that the binary is the one that I trust, and then I send you, and then at T0.1. You change it to be like some binary I don't trust, but in the meantime, I've exfiltrated and then I spend the next hour sending you data. Like the way around this is like force a new attestation before access to the keys.
Okay, so Ecker, I believe you brought up a perfectly valid point. I certainly understand it. Thank you. And the proponents
happy to step
will
down.
need
Thank
to
you.
Do a better job. Appreciate it. But let's move on to the queue. So Thomas.
Thomas was responding.
Oh, I'm sorry. Yuri.
All right. I think a few problems are being conflated here, problems unrelated to each other. One, you want end-to-end secure TLS connection. In the chat, there were debates about proxies. That's not relevant to attestation. You either have end-to-end secure or you don't. And if your environment and your endpoints allow proxies, well, whose problem is that? Regarding limitations of a post-handshake attestation, application layer change is not a limitation. It's a feature. It's a requirement. If your application cares what its peer runs on, then it must handle this. If it doesn't care, why bother?
So to respond to the second one first, I would say that application layer change, I mention it as a limitation because then the business logic, if you have to change that business logic, which means that you have to now apply it for a custom solution for each possible application or each possible use case. So that's in that sense, if you have to modify the application, it's bad. And you want to avoid these kind of application layer changes because the solution should be agnostic. Just like TLS, you have connection, you do it, and then whatever you want to use, you use it there. And to first one, probably Hannes wants to say something.
Yeah. So do you want to respond to that?
Absolutely. In other words, you want a standardized building block that handles attestation, which is not necessarily related to TLS in any way. In fact, it probably doesn't need to be related to a TLS. It requires a secure pipe, and IPsec would handle that part just as well.
I can explain that. So many of the questions relate actually about RATs, about how does remote attestation work, and not so much about what we are trying to do here, namely assuming that we have defined remote attestation sort of concepts already, how do we actually pass them from A to B? And if we look at the regular communication between a client, a TLS client and TLS server, we per se, with the authentication that TLS provides, we don't know what software is running on that device. We don't know what firmware, we don't know what hardware it is. And remote attestation provides us that information in addition to that. So now the question is, assuming that we want to pass this information around for some of the use cases, and Thomas explained one confidential computing use case where the whole promise is, as he explained, to run software in sort of this sandbox in the isolation so that you can't see it. So obviously you need to establish a confidential channel to that, because if you pass your workload that you want to run there in plain text, then of course, like what's the point in having confidential computing environment in the first place? So we need to somehow pass that information around. So if we naively go into this and just send the information, the evidence, as we call it in RATs, If we send it from my device to some other device, what prevents anyone from just replaying it? So there's a freshness mechanism that was developed. So you have a challenge, and you include that challenge in the created evidence structure that is signed locally. But then the question is like, now we have this TLS channel that we established. How do we make sure that this is not the evidence that we pass on top of that channel is not just relayed to some other party? Because I could get a challenge from one side and just relay it to the other party. So, and this is a problem we have solved already in TLS with key exporter and other mechanisms. So we are actually just utilizing these existing mechanisms that have been utilized numerous times in the IETF in various places. So the whole effort is really about, like, we have this work that we generate this remote attestation and want to shuffle it from A to B using a channel where the attestation is bound to that channel, period.
Right.
And so to answer your question on IPsec, yes, you can also define this in IPsec, but for the use cases that we looked into with confidential computing, there people want to use REST APIs. But IPsec would be good, is a cool protocol too. With IQ2, you could do that too.
The main point was that it has to be end-to-end secure.
Yes.
By whichever means.
Yes.
As for being replayed, if it means to different destination, then who cares? Because I run this firmware regardless of who I'm connected to. So
No,
information will remain true regardless if you broadcast it, which you probably do not want to do for privacy
I give an example
reasons, but
of why I care. So
Yeah.
I pretend to you.
Hold on, let me, because we're trying to have the discussion to make sure that the group understands whether there's a problem. So Yuri, I'm trying to understand based on your comments, is it that you're believing there's a problem, it's just not dependent on TLS?
So I would like to quickly respond to that. Thank you, Nancy. So one line answer maybe. So 100% of the confidential computing solutions use TLS. If you go to some other layer, so that means you are now throwing away all the solutions that are there and starting from scratch. So that would be my one-liner to say why. So TLS already exists. Remote attestation is required for confidential computing. Why not combine the two into one?
a lot of things already exist. My point is that attestation of the endpoints, no pun intended, requires a secure mechanism of conveying it. It doesn't and shouldn't care about what exactly that mechanism is. TLS, IPsec, REST API, whatever.
Right, that's a fair point. Yeah.
Okay, we should get going with the queue because I want to make sure we have time to exhaust the discussion. Go ahead, Lawrence.
Hi, this is Lawrence Lundblade. Going back like 5+ years to the original motivation for attestation, for me, it was coming from the client side. It was attestation of the end user devices. And the reason that the attestation of the end user devices is important is that end users get to choose their devices, and they choose all sorts of things, right? They could choose cheap devices, expensive devices. And so like there's many cases where the server wants to know what device the end user is using to know whether to trust the device. Does the service trust the device for a small financial transaction or a large transaction? Confidential documents that only can be shared in certain places or things like that. So it seems, since so much of the application world runs on TLS, that this is like a huge set of use cases that we're really not talking about in the room right now. We're mostly focusing on attestation of the server side, not of the client device side. So I'm basically saying that there's a whole bunch more use cases that are interesting that should motivate this work. And I would think maybe it's the browser vendors that you would want to bring in and have them mess
No.
around with this and see
No,
what they
no,
think.
no. That's not our focus. So the browsers are completely out of scope.
Well, while Euron is coming up, I think the proponents were very clear on the use cases. So if we form the working group, it's not to make it open-ended, just FYI, right? It's not to make it broad and open.
Go ahead, Paul.
Sorry, Paul Wout as AD. I thought that in the problem statement it was either a peer authentication and attestation or a mutual attestation. So I think the use cases mentioned before, identifying your own client and whether it's a trusted enough client, would actually be in scope for this.
Yes, that's correct. And the reason is that we exported authenticators can be generated by any party. So it can be, and that's why we went over to exported authenticators, because the RFC 8446 section 462 and 426, the exporters defined there do not allow the server to be a tester. So we wanted to have bi-directional mechanism, and that's where RFC 9261 was more fruitful. So Lawrence, your use cases are already covered. So you can have the client as a tester. You can also have the server as a tester, but in confidential computing, mostly we talk about server as a tester. That's why we are slightly more focused on that, but your use case is definitely covered. Client can be an attester as well.
Yeah, and to add to what Osama said, we will need to be very clear in the charter about this, because there are major privacy concerns related to client-side attestation, in particular on the open web. So we're very careful to avoid these use cases, and we will make sure that the charter threads the needle not to step into these areas.
So I want to, a couple more comments.
Sure.
One of somebody said that you have to have server authentication before, server attestation before you can have client attestation. Is that true? No. Okay.
No, that's not. So you could have both. I mean, you could have mutual attestation, but you could also have unidirectional. That is, server as a tester, one use case, client as a tester, another use case, and both of them being attested, mutual attestation as third use case.
Yeah. So any of the three combos is okay.
Any of the three will be supported by the same solution.
You know, and then also we dealt with a lot of the privacy stuff already in EAT attestation. All that stuff came up there, and we had some solutions to it. So.
Okay, we need to move the queue so we can ask the questions. Watson?
Hello, thank you for your presentation. One of the use cases you mentioned with the confidential compute, is there an implication that the administrative access to the enclave has to be extraordinarily restricted to enable you to get the privacy equivalent to the third party that you want? I think that's sort of behind some of the questions about, well, if you can change the firmware, what's going on here? It's just sort of administrative access in general would have to be very restricted there. It's very different than cases like the disk encryption thing, where you're fine having that encrypted access, or you're fine having that administrative access because it's your keys, your transmitting devices you control, whereas in the confidential use case, there's sort of a third, there's mutually distrusting parties trying to all interact with the same shared thing.
Do any of the proponents want to? Okay.
Can you echo the answer?
Yes, the answer is yes. Mark.
Mark?
Hi. So I guess I represent a practitioner here. We have a very large shop at a big multinational bank. So
can you speak please closer to the mic?
I'll just walk through my concerns. So number one, here we're introducing a very highly available third party into the TLS exchange. And that party must always be on, always must be reachable, Such things are already very complex and expensive to operate, like your identity services. And here you're basically saying it can never have any downtime, cannot even upgrade it without incurring downtime. So like, it's an engineering and operational challenge. Number two.
Sorry, before you go to the second, just to clarify, where are you reading from? Is it in one of the slides or?
I'm just saying what you're doing here by introducing another party into an exchange between two parties. That just
what is that
when you
party?
export it, when you export your authenticator, you have to go contact somebody to tell you if it's
No,
good.
you don't have to. So authenticator is the TLS peer, so it's only going on between the client and the server. That's it. There is no third party.
Okay.
So authenticator is the client. If server is the attester, the client sends over an authenticator request according to RFC 9261. And I will emphasize again that this is just an initial proposal.
Okay.
We are open to other proposals,
Right.
but this is what we found the best from our works of several years. Authenticator request is sent by the client. Server is the tester. It generates an evidence, and then it puts back in the authenticator service message, the certificate message of the authenticator extended by that PKI certificate, which sends it. There is no third party. There is an end-to-end connection between
That's
the two.
actually, okay, so I want to go through the rest of my list, but let me just mention that's probably even worse because now you have to change every relying party every time you upgrade anything. Because
we
you
are
change
not
the reference values, but we
that's,
can come back to that.
Just to quickly respond to that. So because you say it worse, so just to quickly respond to that, that's not the final solution. You could have a verifier which could do some things for you, and it's an open space. We are open to discussion. We are not limiting it to the relying party. It could be done in passport or background check model of RATs. Our solution supports both.
So I guess the high order bit is consider load. Number two is you need to figure out, and maybe you already thought about it, how to combine different types of attestations. So like platform attestation for where you're located with workload attestation, what type of app it is. And I haven't really seen how that's done here.
Yes.
If we are going to deploy, say, SPIFFE for identity of workloads, then I would not want to deploy yet another separate solution to do this. There is some concern that you would need to
sorry,
update.
before you go to the next concern, let me quickly respond to this one. So we are not limiting to any format or anything. So it's just the protocol will just contain that evidence. Whether it's evidence could itself be a platform evidence as well as the workload evidence. And ARM CCA, one of the proposals, one of the trusted execution environments has exactly that. And we have formally analyzed that, meaning that you have a platform evidence. On top of that, you have a workload evidence, and you can bound the both and then send it as an evidence, send it as a composite evidence within the TLS handshake, within the certificate message of the authenticator.
Okay, so I suppose if we were to invest in SPIFFE or something else, and then we have to do something separate for this, that would be non-starter, just for your information.
So can I just put a pause here? Because I think you're jumping to what a solution could look like.
More like requirements. These are requirements, like you need to consider.
Understood, but the requirements can be shaped as part of the charter as well as part of the requirements that lead to the solution once, if this group decides to form a working group, that's what gets defined there. Right now, we're just trying to get to the question of, is there a problem? Well, I think we're trying to get the group to understand, is there a problem here that we need to address?
Yeah, so let me propose this. We're going to stop, and I'm going to propose 2 questions in a poll. So make sure you're logged into the data tracker so that you can answer the poll. I want to be very clear on the separation of these 2 questions. Okay, because the first one's going to be, do we understand the problem? And you'll see the wording in a minute, right? Is the problem space well defined? That is very independent from, is the problem solvable and is a solution there? So what I want to know first from people is the problem well defined itself? And then we will ask, do you think it's a solvable problem? Because that seems to be a lot of what's happening here today. So
would the chairs allow me to have 1 sentence summary of what the problem is before we go to the questions?
Sure, that's reasonable.
Okay, so what we are doing in simple words is TLS provides you the identity verification, and we want to add on top of that, what is the hardware, software, firmware running for that specific bound to that machine. So that's the simple thing. We append to that identity verification, what is the state of the software, hardware, and firmware. That's the simple idea.
Okay, thank you.
Thank you.
All right, so the question's on the screen, and I'll raise it, although people are already voting, which is, raise your hand if you believe the problem is well enough to define for the IETF to consider solving. That does not mean that it's solvable. Don't raise your hand, so specifically, actively don't raise your hand. One of the oddities of Meet Echo, you actually cannot raise your hand if you don't think the problem is well defined. So we don't understand the problem space.
You know, Wes, we have yes and no now.
What did he say?
He said yes or no. So don't raise your hand, doesn't it?
Oh,
Yeah.
okay. The interface keeps changing. Thank you, Ecker. So say no if you don't think that the problem is well defined.
Can I vote as well?
If you log in. Yeah, you can sit down. So go ahead and sit down at this point, and we'll figure out what we're going to do next after we get the answers to these. So.
Usama, you can have a seat. Just, oh, yeah.
So a no means you don't believe the problem is understandable. So no opinion. They don't know how to answer the question. It happens. I'm confused means no opinion. All right, so is somebody taking notes? Can somebody write that down in the notes?
Where are our note takers?
Oh, okay, excellent. All right, so with that, a little bit of silence, please. This room's very echoey. Okay, so with that, the answers are 51 yes for those that can't read the screen, 10 no, and 16 with no opinion. Now I'm going to pose the second question. 1 second. This is going to be the interesting one. Okay, so this one's the opposite, which is raise your hand if you feel this problem is solvable. Not with this specific solution necessarily, just is it a problem that the IETF can possibly solve? Or, say no if you don't believe this problem is solvable at all. Okay.
You guys never fail to amaze me. That's all I can say. Having run enough bots.
We are kind of sitting up here in shock, to be honest, after that dialogue. So the yeses are at 53, the noes are at 2, and the no opinions are at 21. One way that I interpret that is that we do believe that there's a problem here. We do believe, the IETF, we'll get to the IETF question in a minute, but that there is a problem and there is a solution to it. That does not mean that the proponents necessarily have the solution that the audience wants, and I think that might be some of the takeaway, that like all IETF work, we want the whole body to come up with the solution that everybody agrees to, of course. And so everybody knew that coming in. That's a very good result. Thank you. I think I will ask one more, which is the IETF the right place to solve it?
Before we, I actually have a question before we.
Ecker, go ahead.
Yeah. So I saw a lot of like companies' names on those slides, and I thought what fraction of those companies actually want to solve this problem, as opposed to we'll ignore it if we do it. And I thought I heard a little bit of allusion to that, but maybe you can get.
Could you start over? You're breaking up pretty badly.
Okay, I'm not sure what I can do about that, but I'll try.
Speak slowly.
I saw a lot of company names on those slides. What fraction of those companies want to solve this problem here at IETF, as opposed to will ignore us?
So I think I'm going to get to that, because one of our solutions is who's willing to work on the problem. And
Well, I know,
right.
but we should ask that before we ask if the IETF is that's a predicate question. If the IETF is the right place to solve it.
I can flip the order. I'm fine with that.
Okay, so we're gonna rephrase the question. So just give us a minute, because we're gonna flip the order, which is what vendors would be. So if we were to form, if the IETF were to address it, just let me finish, right? Who would be willing to work on the problem? So we could break it up into two parts, be part of the design and be part of the review process. This is who wants.
So how about this one is, who is willing to participate in the working group in order to work toward the solution? That could be as an editor, it could be as a reviewer, it could be as a dialogue in the discussion, work on the mailing list. Are there enough participants here that want to work on this problem that we can consider it?
We're just making sure you guys are awake.
All right. So with that, looks like there's 28 people willing to work on it, 14 that aren't interested, and 20 that don't have an opinion about whether they're going to work on it or not.
All right, so the next one, Ecker, I think maybe to your point, is not only are those that want to work on it, but who's actually going to implement and deploy it? So give us a minute. You got it? All right.
I'm sorry, but this still isn't my question, because this could have 10 people in the room and there could be 100 vendors of which 87 are not interested, and that would be bad. So like really what I'm asking for is to get some sense of of the people on the slides that I saw have already deployed these solutions, how many of them are interested in this? And I'm asking the proponents to tell me that. Not a poll of the people in the room.
So there's no way to put that into a poll. So let me ask this.
That's why I asked it as a question for the proponents.
Okay, so if, why don't you unlock the queue? So if you are a company or a representative of a company that can state you're willing to implement this, in your company, so that we separate individuals from actual companies that are, interested in implementing and deploying it. Put yourself in the queue so that you can state that. And we'll let the poll continue, for the moment of who is willing to implement and deploy as well. But why don't you go to the first in the queue? Is that?
Go ahead, Mike.
Mike, thank you.
Hello, audio test. Yeah, I just want to make the procedural point that I have a sneaky suspicion that we would not get convergence on what are we talking about. So I propose that we need to bat around charter text. And if we can't get the charter text to converge, then we'll have some sort of answer about whether we can agree on a problem statement.
That's coming next.
I think it's premature to try and say, should we work on this when we haven't clearly defined what this is.
It is coming next, and that's a fair point. We'll do that shortly.
Where's Hank? You're next in the queue.
So this is Hank, not representing company. I find this is a weird way to ask this question. I want to have this in the minutes. And yeah, even if people come up here now and say affiliation names, which is again weird, there are a lot of companies not here. So the same problem. So I don't understand what we're doing here right now.
David Skenazy, Google, not a representative of Google, not speaking for Google. They just pay for my flights here, which is quite nice. So I agree with Ecker's concern that, and we've done this a bit in the past at IETF, where we've built solutions that then no one implemented, and that's a failure of a working group. It's even worse than not doing the working group because we spent the time on it. Speaking for, I've spoken to teams at Google that work in this space. They've built something using the noise protocol right now. I'm not saying the IETF should come and standardize noise. Let's not open that can of worms. But I'm not seeing any motivation yet for them to switch to something new or to a standard that the IETF would do. So I think to Ecker's point here, it'd be really helpful to get a better picture of which folks, why does other things not work for them? What do we need? And I think maybe batting around charter text would help with that. But for example, for myself, I'm not convinced that TLS is the right protocol to use for this. We could use something else. And so I think once we get to a point, I suppose the charter would scope it to TLS potentially. It'll be easier to answer those questions and to see what those are. But I think right now, I answer no opinion on a lot of these questions because you said that's what we should click if you're confused, and I've been kind of confused.
Okay, so given these comments, it really does sound like we should move to the charter text. Okay, so I think unless it's really quick.
Yeah, I just wanted to state that as Linaro, we are committed to an implementation in open source, one or more. But
Okay.
yeah.
Thanks. Yeah, I mean, the quick comment I was going to make is, some of the vendors for Ecker and David are the ones that seed that then, I often have customers that will wait until something gets standardized. So it's hard to name the companies, so to speak. So I think with that, we should just move to the proposed charter.
Okay, so I think the way that I'm going to do this is I'm going to run through all of the slides just so that you see the full charter. You can't put the full charter on an IETF screen. It just doesn't work. So we've broken it up into a number of slides, but I want you to see everything that's coming, and then we'll go back to the beginning and look at it in pieces, right? So the first two, we have a background and motivation that's going to take up 2 slides that sort of, give where we are and how we got here. There are 2 slides on the scope, what the scope of the working group will be, what the goals are sort of, and it talks about, what's both in scope and out of scope. It talks about a little about the background of, where the working group should start considering things. We'll come back to that in a minute. And then there's a slide on dependencies and liaisons. How are we going to work with RATs and TLS and other things as well? So with that, I'm going to go back to the beginning. I'm going to leave it up for a minute. You can join the queue if you want to talk about this slide in particular, but I'll leave it here and let people read. I'm not going to read it out loud because you don't want me to do that. All right, I'm going to go on to the second page of background and motivation.
Mark, you've got a comment? Oh, sorry. Go ahead, Paul.
So I have a comment here. I think the post-handshake exchange is something that will trigger people because that is very narrow focused on the one solution proposed. So I think the charter should actually say solution based on exchange within TLS or something like that.
So I think that the issue of incorporating attestation into how parties talk to each other over secure channel is very, very clear. We need that. Whether, like this immediately jumps into a solution. And my analysis indicates that this is not going to work. So I think it would be best to pull back and go back to what problem we're actually trying to solve before we go into saying we're going to solve it this way. If I were to guess, it would be it would go back to separation of concerns. Deploy the credential first and use it with unmodified TLS, if I were to guess.
Ben? Benjamin Schwartz.
Yeah, hello. Yes, I think that limiting it to post-handshake exchange smacks of choosing the solution. Also, there are a bunch of previous attempts at this. Probably the most prominent is RA-TLS. I would not want the charter to, in fact, I would like the charter to encourage the working group to support existing standards, or sorry, existing pre-standard technologies that achieve this goal where possible. There's no, let's only invent things when we have to.
So Ben, clarifying question. Would you like the working group to do a better exploration of existing solution spaces to possibly consider? Is that what I'm hearing?
So I think that the charter text line that I'm looking for would be something like the working group will prefer pre-existing solutions where possible.
Thank you for the concrete text. Who's next?
Hopefully I sound better now. So it seems to me that the key restrictions here on this text are no change to TLS and the post-handshake statement. So I think no change to TLS, like that seems to be an inherent decision that needs to be made, but I think it's the right decision. Otherwise, this should be done in TLS. So I think that's the right premise for this working group. I think that I'm less certain about the post-handshake. I have some nitpicking about the term post-handshake just because it has a technical meaning in TLS, but I think we can fix that part of it. I think the real question is whether, as previously indicated, this should be attached to like the credentials or it should be attached to the TLS handshake. I actually do think that if we're going to do this, we should take a position on that topic and that it should be attached, and that because those are entirely different design spaces. And so there's still plenty to do, even if you decide it should be attached to the handshake or attached to the connection rather than attached to the credential. So I think this text actually is kind of reasonable. Though I think you could also strike out the post handshake and just say that no changes to TLS and that it must be fresh.
I mean, from what we've heard so far, I think there are multiple people that think we shouldn't lock it into post handshake, and that's a fair analysis. So I'm sure Paul will take that into advice when crafting the final version of the
So
charter.
I guess my thesis is actually not so much that it should be or should not be locked into the connection, but I think that the working group should be formed under the premise that either it's tied to the credential or it's tied to the TLS connection, and should not leave that discussion open, not to let that question open later, because I think there's just totally different design spaces, and I think it's going to be really difficult to come to consensus under those circumstances. So I think the working group should be formed under one of those premises, not either.
Watson?
Hello, sorry, there's a camera. All right, great. Hello, I think that there's a problem with the charter where there's a whole number of sort of architectural questions related to how does the evidence you get relate to the properties you want to guarantee about the system, particularly in the in sort of the shared trusted third party use case. And I feel that as written, the background and motivation here mean that you can end up with a result that sort of doesn't get you the security guarantees you would really need to deploy that solution and get reasonable privacy and security properties out of it. And it's fine to punt on that, but I think we should do so explicitly in the text.
So if you wouldn't mind sending text that you think that would get to that, probably to the mailing list, and we can consider adding. Note that the next couple of slides are actually the scope that sort of better restricts it. So what you're saying may fit better there as well.
Yeah, I'll see those slides and then send text if that's solved.
Jonathan?
Hiya, can you hear me?
Yes.
So I would say one important thing that should be in this bit of the charter text is it should be bound to the TLS session. And then you don't have to specify whether you want it to be post-handshake, pre-handshake. You just have to say it's bound to a TLS session. And then you're not picking a solution, but you're describing the property that you actually want to get out of it.
Right, so I don't have a specific charter text to suggest, but I would like somewhere in the charter to say that this shouldn't do a really crap job of privacy, and if it's going to head that way, it should be stopped and killed. So I don't know how you write that down nicely, but something along those lines I think is needed because there is clearly some possible ways to go wrong here.
I think what you're suggesting is that all future charters should have a privacy consideration section.
No, but I think this one should have some text to the effect that if it's heading in a direction that's doing really terribly in terms of privacy, then that should be a reason why an esteemed AD can come and stomp on the whole working group, for example.
So a clarifying question to you. I think you don't only mean privacy. I think you also mean abuse of attestation for vendor locking and things like that, right?
Yes. Yes.
For vendor locking of like websites and okay.
Yeah, Paul put it better than I did. So.
I just want to respond quickly to the concerns which are being raised to the proposal. I mean, it's all the time saying that it is bound to, so not saying really bound in that sense, but that's what our intention was. That's what I understood from Jonathan. So that is basically all the time saying TLS is the binding and not RFC 9261. The starting proposal already takes care of that. There is a binding to the underlying TLS protocol, which means that basically we are not saying that it's being done independently. The whole idea is that I want a status of the machine, which is the one which I get in a PKI certificate as well. So the two have to be bound together. That's very clear in our minds at least. So if we can definitely rephrase it in a way that it's written like to be more understandable.
Okay, thank you, Britta. You've been very patient.
So this right now is written for attestation, and there's been a lot of discussion on authentication as well. I would say because them both being discussed, it'd be nice to have this very clear about whether authentication is in scope or out of scope. If it's out of scope, that's great. I think attestation is nice and clear, and we can just say this does not cover authentication. If it may, Yeah, exactly. Exactly. So that's getting to the second question. So what was just mentioned is which authentication, if we do include it in scope, what are we allowing to be authenticated in terms of what are the endpoints, what are we considering? So just being clear about this part of do we allow it at all, and if so, up to what bound? And the second comment here, bridging further on that, if we do allow authentication, I think it's very important that we make sure that this is clear of what that intent is to be separate from TLS. I could easily see this branching into, especially in a post-quantum setting, of an argument of this working group now handles post-quantum authentication after the handshakes. We just do a chemical establishment for TLS and we figure out a way to retroactively add authentication. It gets very messy in a fork at the TLS working group. So I would encourage that we are very clear on what specific roles this has versus what TLS is doing.
Thank you. So I will note that the scope section coming up is where we can actually specifically say what is in and out of scope. That's more than just the background. Hank?
Yeah, sorry, I wanted to follow up on that, and here we should do this in the scope section now. But let me just quickly say, no remote attestation without authentication of the attester and therefore the attesting environments. I would say that's a hard must. This is my opinion, but yeah.
I think some of the points that are made here on a microphone, I think they would not fit well into a charter text because they're so detailed into some requirements and some security goals, and it needs so much context to actually understand. Like specifically, it's the last one was the authentication part. Like are we talking about the authenticating your tester with the evidence with some different keys? Then you need to explain what these different keys are and so on and so on. So I think that almost sounds like the solution work that will follow afterwards, and there would be a separate document that needs to explain all of that.
That's always the trick, is getting a charter that's not too broad or too restrictive. Daniel?
So I like the current text. I like that we relax the post-handshake exchange. I also like the comment from Jonathan to bind that to a session. One comment I'd like to make also is that regarding the companies that are committed to implement that, I can say that there is a full industry that is looking for a non-proprietary solution that does this job. So I think I'd like this job to happen. I mean, I can say 3GPP, Etsy. That can.
Yuri?
I'm still unconvinced that a binding to TLS session is a good idea. In fact, so far, I've been convinced that it is not a good idea. If your certificate authenticates your host and your attestation record also identifies what it is applicable to, that should be sufficient. And if they do not match, once again, whose problem is that?
Sorry, Paul. Can I just I'm trying to understand what you're saying. So let me try and rephrase it. Are you saying that using the TLS channel and then getting an additional information payload that attests the remote environment is enough, and you're just using TLS as the secure transport for those payloads? They don't have to be cryptographically bound together. Is that what you're saying?
That is correct.
Okay.
Just really quick, why I was I had hard language about authentication is required for a tester identification. There's been an IB statement about that. There has been a reply by the CCC, the Confidential Computing Consortium, in the liaison statement. That has been a contentious topic, and I think in that space already this authentication requirement came up. That is why I'm bringing it up here again, so we're not clashing with well, previous decisions. Just as a note.
So I completely disagree with the gentleman who was here saying there should not be a connection with the TLS or any secure channel. I mean, that's absolutely wrong, because if you don't have a connection to the underlying TLS mechanism, that's completely broken. You could have evidence from one machine and then you are talking to another machine. So that's, you are getting a state from one machine, you are getting an evidence of the identity from another
Okay,
machine. That's a
so let's
completely broken
stop
solution.
that, because we're into solution space. We only want to talk about the charter right now. That's something that we can battle in the working group, and it'll be a great discussion there. All right, so seeing the end of the queue, I'm going to go on to the scope. So I'm going to give everybody a couple of minutes to read the scope statement. Remind you that there's 2 pages of this.
Let's show the second one, just because they're kind of tied together, before we take questions.
All right, Dave.
All right, can you go back to the first scope slide? All right, so first, I don't know if there's any specific meaning between the lowercase 2119 words of the first 2 bullets using should and the last one using must, or if those are synonymous. And so maybe that's an opportunity to clean something up if those are all supposed to be the equivalent of must. My main comment is in the last one. The term per session freshness is probably a fine term, but it's not defined as such in 9334, whatever the RETS architecture is, just freshness, where it has multiple meanings, right? Freshness of attestation results or evidence or whatever. And so I think the charter should be cleaned up, and instead of using per session freshness, use a definition, or alternatively define the term in the charter, as opposed to leaving that term up to the working group to define, because I think this is a requirement with a must that's in here. Other than that, I think we're...
Very good point. Thank you very much. Ecker?
Yes. So I agree with this per session freshness. Also, session is not really a good term to use here. I think what you want is connection, if anything, because TLS is a very specific set of properties around sessions. I also don't understand point 3 here in connection with the next slide, which says we're not extending TLS, because I don't understand how you're going to negotiate things within TLS without extending TLS.
That's a fair point. What would you suggest we change?
Well, I think I'd like to understand what this is trying to say. I mean, maybe the solution is to drop the point in the next slide. I mean, the solution is to drop the point in this slide, but I'd like to understand what this is trying to say.
So there's an audience member that suggests we delete bullet 3. Would that suffice?
Well, I worry the problem is actually on the next slide, based on the so it's like concretely the draft that we have here defines code points for using the TLS handshake. Now I happen to think that's wrong, but it does, and so presumably they don't mean they're not going to extend TLS.
Yeah, so I think I would look to Paul for clarity of if this goes forward. You've heard, whether we should use TLS and how bound it should be, and how open the discovery mechanism of existing solutions and all of that kind of stuff. So I think there's a fine line to walk with the ultimate charter text of how constrained it is or how open it is, right? Do you have thoughts there?
Yes, so I think the intention here is to say we might create a new TLS extension that does things, but that doesn't really change any of the core functionality of TLS itself, other than maybe at the end say, I'm not setting up this connection because this other attestation information told me this connection is not secure to use.
Okay, so I think, Ecker, with that, take your comment well said, but I'm not going to solution engineer that right now. So.
Okay, Jonathan, you're in the queue.
Just to follow up on what Heka said, sorry. To me, it seems like what the text should say is no modifications to 8446, which would leave extensions in scope, but changes to the key schedule out of scope. So I think that's fairly clear text you could use.
That's fair. Okay. Tom?
Tom Michers. I'm still a little bit confused about what exactly is trying to do here. Are we trying to build something that is layered on top of TLS and that you have just a channel binding between the two things? Or are we trying to inject new properties into the security guarantees of the ongoing TLS session? And that would be, I would call that changing TLS as a cryptographer. And if we're trying to do the second thing, then I don't think the text that's here makes sense. And if we're trying to do the first thing, then I think a lot of the other things that have been said also don't make sense. So I'm very confused about that. And I think that should be probably resolved before settling on final text.
To respond to you, so the reason for coming here was that it would be layered on top of it and bound then to the TLS channel. So maybe that point is indeed item 3 in the bullet list is probably misleading. We had an earlier effort that we explored that incorporated sort of solutions into the TLS handshake, which was solution was presented in the TLS working group, but that would clearly fall into the TLS working group scope, and that's had other issues. That's why we ended up with this one. So I think I would, if it's up to me, I would delete bullet number 3.
Can I, just to respond to that, Tom Wiggers again, would it then maybe make sense to drastically reduce the amount of text in this charter about TLS and say, we're defining a protocol that will define a binding mechanism to TLS4, and the protocol will have these security goals?
There were obviously many ways to write text. And like I personally, obviously biased a little bit here, think that's a good enough approach, or like one possible approach that just explains how the scope of the work is. But I'm not married to the text.
Yeah, I think, you know, the chairs and Paul and others will work together, and the text will be refloated on the mailing list at some point. This won't be the end of trying to problem solve the scope here.
Yeah, I think that less language about TLS here will probably lead to less confusion about which way you're trying to go. That's just what my opinion, as again.
Okay, thank you.
Sure.
Usama?
Okay.
Usama.
So very quick, just to remind all the people. So the reason we are emphasizing a lot on TLS are two. Number one, as I said, 100% of the solutions in confidential computing use TLS connection. They don't use any other solution for confidential computing. So moving on to any other protocol would mean that you throw away all the things that exist and moving on to a real new solution. That's not possible. I mean, or at least not practical for now, and nobody will deploy that new solution. So we want to be consistent with what Confidential Computing Consortium has now done. And that's why we are emphasizing a lot on TLS. And to answer the question that was just asked by Watson, so so the point of putting in TLS and its binding is that basically we might need some extensions in order to negotiate like the different zoo of all the evidence formats. Intel SGX, Intel TDX, ARM CCA, AMD SEV, AMD SEV SNP, all the formats. It might be a requirement that we might need an extension within the TLS to negotiate different formats, which it wants. That might save us from the hassle of doing one round trip after the TLS connection is established. So this is just a flexibility point that we do not want to just limit it to post handshake, but still keep the flexibility that we might need to, or some people in the Confidential Computing Consortium might need to negotiate the formats already within the TLS handshake.
Thank you. Ready?
I'm back in line because you said that my prior comment was punted to the scope section. So now that we're at the scope section, copy paste everything I just said. We need something in here about whether or not authentication is in scope. And if it is, what is in consideration for authentication? If it's not, fantastic. Particularly, this says that we do not, that we use TLS as is, but does not clarify what the impact on TLS of this working group should be. Is it simply attestation to the endpoints? This is to Tom's point about, is it a wrapper protocol, or are we trying to influence something about the security of TLS?
Hannes?
Yeah, again on the authentication part. So there are different authentication steps happening here, because, for example, the evidence that comes from the attester, again using RAT's terminology, that's digitally signed. So when it's received by the verifier, you obviously verify that signature as well. So there's an authentication step involved here. But then there's also like the regular TLS, which we are not changing in any way. So like if I use, let's say, mutual TLS, you have the endpoints being authenticated. So which one of those very different things are we talking about when you say we are not talking about the X509 authentication in TLS? It just happens whatever there is. I don't think we need to, like, there's so many requirements that we need to describe somewhere, and I don't think they should all go into the charter. Like, this is that there's always a temptation to say, oh, it has to do privacy, it has to do the replay protection, it has to do confidentiality protection. What do we mean by confidentiality? And so on. We can't put everything into the charter.
So Paul, let me respond. So I think what is being attempted here is to enhance a TLS connection so that it can be trusted better for talking to remote endpoints. It is not modifying the TLS connection, and I think there are some different opinions in the room, but I think that a binding of the two cryptographic states of the attestation and the cryptographic state of the TLS connection in itself is not necessary, because you're using TLS as the channel to exchange these payloads in. And so I think that's where some of the confusion in the room comes from, whether it is bound or not. And that definitely, we need to clarify that in the charter.
So it's the clarity here is where we are having the issue. It's not about what the intent is that what's in or not in scope. So right now, as the charter reads, and one of my concerns is that this could be interpreted as authentications in scope. We're going to do some sort of extra authentication on TLS not related to the endpoint attestation, because technically it's allowed here. That's essentially the description, or it could be interpreted as that. So if you're talking about the endpoint and authentication related to attestation, and that being the sole focus versus TLS authentication, there needs to be some sort of separation there. Clarity of where TLS working group ends and where this one begins.
Okay, I think that's a good comment. In order to, we don't have much time left, so I need to move on to the next, Yaroslav.
I would like to ask a clarifying question about that. The chairs allow?
No, so I need to make sure that we get, so put yourself in the queue and you can ask it in a minute.
Okay.
So effectively building up on top of what was discussed, as far as I understand, essentially the proposal is a shim layer, a protocol between TLS and application layer that's afterward, that is providing attestation. And indeed, current scope doesn't seem to be clear in terms of demarcation line between TLS and attested TLS. So is it a separate protocol? Is it an extension of TLS? Is it an application layer thing? It's a little bit murky at the moment. That's the way I see it.
Thanks, Deb.
Hi, Deb Cooley, no hat, because I can. Shoot, I forgot what I was saying. Okay, so I have 2 points. First of all, I do think that this group needs to be more open to the uses of secure protocols beyond or in addition to TLS, if that is the best option going forward. So for example, if IPsec were to work better here, then one should use IPsec. So if IPsec is not suitable here, then TLS is fine. But if IPsec is really much, much better in this situation, then IPsec should be used. So I do think that one can't stand up and say, oh, we have to use TLS because that's what we've been using, right? So that's my first point. My second point is I do think there needs to be a binding between the TLS handshake and the attestation. There has to be some sort of binding, some sort of channel binding, something. You can't just establish the channel and then use it, because then that can be abused. I mean, that's been proven over time, right? You can. You have a hat on?
That's true, with hat. If, let's say, if both the TLS, the TLS exchange has a fully qualified domain name and the attestation also includes a fully qualified domain name, do you consider that bound, or do you need some cryptographic property to bind them?
No, I just need to use something within that you get out of the TLS handshake to be used within the attestation layer to bind them together.
So ADs, you're solution engineering a little bit.
It's called ES. It has been done before. I saw that. It has been done before. EST does it, right? They use a channel. They use a channel mechanism to insert into the request, right? So you can do it. It's not hard.
Usama? Usama?
So I wanted to quickly point out that the Confidential Computing Consortium, which was mentioned in the chat, so I am leading 2 projects there, and Confidential Computing Consortium Attestation SIG, which includes Google and all others. So basically there, it's very important to have this kind of solution. So that's what I wanted to just clarify.
Thank you, but we need to stick to discussing the charter right now. Lawrence?
So the UCCS draft suggests TLS can be used to secure the attestation evidence. Is there any relation to what's suggested in TLS, in UCCS, to the work here? I think that also begs the question a little bit about the key material used for TLS authentication versus the key material used for attestation.
That could be discussed as part of the solution. You're on?
Yeah, just back to the authentication versus attestation question. And here I represent myself only. I don't think we had an explicit discussion about that. My assumption is that by the end of the TLS handshake, the 2 peers are fully authenticated, and then it's a yes/no decision whether each of the peers accepts the attestation by the other side. Would that answer your question, Britta?
Okay, I think we're going to have to keep it brief because we're almost at time and we need to let the AD do final comments. So
yes,
quick. Okay, thank you.
I think that's our clarity. Would, like, if we just say we use the authentication bootstrap from TLS, then it's some clarity there.
Okay, so Paul, any final words before we close down, or anything else you want to hear from the group?
You have 2 minutes.
So thanks everybody for this discussion. It was very useful discussion, very good, very polite. I'm really happy to see that. So this is a good BOF. I've also learned now that never to predict the outcome of a BOF again, because I was expecting many more conflicting opinions and ideas, and what I actually felt was that we're actually moving towards a solution that we can all a charter that we can all work with to work on a solution. So I think we're actually improved quite a bit on this session, and I have to see whether we have to do a second BOF or whether we can maybe jump from this during the next 2 months into a working group or not. I think the progress has been made, and I'm really happy, and I'll reach out to everybody involved, and we can keep continuing this discussion and work on it.
So before we close this out, you want the proponents to continue And we have a mail list.
Yes,
We'll
sure. Yeah.
continue to work on the
So
charter.
everybody who is interested in this, please use the attested at IETF.org mailing list, and we'll keep on working on this on this.
All right. Thank you, everybody, for coming.